Welcome. In today's video tutorial we will be designing and construction IoT-based automatic fish pond feeder. This project model design has an IoT platform where the model farm is monitored. The dashboard has where we can measure the level of cleanliness and dirtiness the model fish pond water is, with 100% being the dirtiest. We can also see the percentage of water level in the fish pond. And there is a button where feeding can be controlled. These two plates above shows where we can put the fish feeds, and over here is the solenoid valve that allows water clean entry, and below is the valve that drains the water when it is dirty. This is our own homemade turbidity sensor we use to measure cleanliness or dirtiness. To feed the fish, we press the button on the dashboard and it rotates the cups, thereby feeding the fishes in the pond below. If the water level in the pond is low as shown here, it is reading 10%, the system can automatically supply clean water into the model pond provided there is water in the storage tank. And we can see clean water pumped into the model pond, and the level of this water rising is measured by the ultrasonic sensor mounted on the top of the model fish pond. We can see that the clean water in the model pond has increased to 25%, and it will keep increasing until it gets to full level. And when this water is hazy or dirty enough, the system automatically drains it. Now let us take a moment to get to know how this was done. If you like this project design, kindly like and subscribe to our YouTube channel and enable the notification button to get awesome videos we will be making in the future. First, we begin with the schematic diagram. A more detailed explanation of this can be found in the description below. We use the Node MCU board to control the actuators like the 2-channel relay module. In the schematic diagram above, this is represented with a common emitter transistor diagram with flyback diodes that is used to trigger the relays. We connected the two servo motors signal pins to PO pin 3, D3, and PO4, D4, on the Node MCU respectively. The ultrasonic sensor power pinout were connected to 5 volts power rails of the VCC and GND pin, whereas the echo and trig pins were connected to the D7 and D8 on the Node MCU. Please note that the power supply is rated 5 volts and the solenoid valves are alternating current voltage powered, hence the need for a relay to energize them. Once we are done with the schematic diagram, we proceed to the coupling and assembling of the project design. Once the soldering is done, we encase the control side of this project design in a 3x6-inch box. The wirings were neatly fitted inside using cable ties. The LED indicator blinks every second when the design is connected to the IoT platform, as shown here. The two solenoid valves are strategically attached to the plastic model of the fish pond. One of the valves is placed at the top where gravity can help increase the pouring and pressure, whereas the draining valve is placed at the bottom to ensure all of the dirty water is effectively drained away. Now that we are done with the coupling and fitting, we needed a storage tank to put clean water into the model pond. For that we devised a bucket. This will serve as that. Now, let us test the project design.
Okay, so over here we have the IoT platform on the mobile device, automated fish pond system. Here we have the pond dirty level, which is at 36%. We have the water level, which is at 10%, and we have the feed button level. And here is the pond. This is the one of the feeder. Here is the other feeder, and here is the first solenoid valve that is reserved for pumping water into the system, and here is the second one reserved for draining water from the system. Alright, so just a quick recap. We can do this We can control the feeding, like I can press a button and it's just going to feed. I can turn it off again to stop feeding. Okay, now so the water level here is actually at 10% over here. So let's try and like pump in some more water. Please help me do the honors. Okay. Alright, so we actually sending water from this place, and from here you can see that the pumping, yeah, go ahead. The pumping is actually pumping, and we can see that the water level. Okay, let's wait for some updates from that. Right, nothing yet is coming up on the water level. Okay, it's increasing, so that means I will definitely need to pump more water. Okay, the water height is at 30%.
That would be it for us on this video. See you again next week. Please leave comments below if any questions.